Hello Internet and fellow network engineers, my name is Maxim. I share network design tips and tricks with you on my channel. Would it be nice if you could provision the device just by plugging the cable to it? Actually you can, by using zero-touch provisioning, and this is the topic of today's video. We'll cover the present and the future, and I'll conclude with a lab demo. Let's get started. This will be for the devices running Junos or Junos EVO operating systems. And the agenda will start with a definition of what ZTP is, what are the components of ZTP and how we use it. Then we'll cover supported hardware and software. We'll talk about two types of ZTP. We'll cover popular design approaches to ZTP. We'll touch the DHCP solutions with the two options and practical examples for Junos and Junos EVO. And we'll talk about IPv6 ZTP. We'll glance in the future of ZTP. And we'll conclude with a lab demo. So let's start what ZTP is. Zero-touch provisioning is functionality in Junos and Junos EVO devices, which helps you provision the software version and the configuration file on the device with the minimum manual intervention, ideally zero intervention. What are the benefits for you in your network? First of all, it decreases time needed to bring new equipment to production. So it again helps you upgrade and install the configuration quicker. It minimizes manual intervention, less possibility of an error. And finally, it accelerates deployment of a device in case you have or need an RMA. What are the components of ZTP? First of all, you will need a network device running Junos or Junos EVO of a supported model running the at least minimum software version. Currently present in the amnesiac mode, which is factory default state when you take it out of the box, or if it was zeroized before with the request system zeroize command. You will need DHCP server and you will need file repository with HTTP, HTTPS, FTP or TFTP server. This is all authentication-less, so the FTP should be run in anonymous mode. HTTP and DHCPS should not require authentication. TFTP is supported but is not recommended due to unreliability. And finally, a network connection to connect all the pieces together. Let's talk about the ZTP process overview. So this is a simplified diagram. We'll start at the top from the start oval. Initially, when you take the device out, you connect it to power, it starts booting, and you connect it also to a network via onboard interface or a management interface. The device boots up and starts ZTP process. It starts sending the DHCP messages out of the selected interfaces, which is platform specific, and it tries to get DHCP address. If the DHCP address cannot be obtained on any interface, this cycle starts again, and basically everything restarts, the ZTP, not the device. If the DHCP address is assigned, next step, the process verifies, do I have enough DHCP options to run the further step of the ZTP? If not, you can see it goes to phone home ZTP, which we'll touch in a bit. But let's say we have a minimum set of DHCP options. And another thing which is important, what is the minimum set, right? So you must at least provide information how to reach the repository, the IP address of the repository, protocol, and custom port if you have used custom. And also you need to provide either configuration path, if you just would like to use configuration only without touching code, or code image only if you would like to do just the upgrade without configuration, or both if you would like to do both. If minimum set is received, then the device tries to attempt to download the image and configuration files. If download is not successful for any reason, the process just starts from scratch. If the download is successful, it compares. It starts with a code upgrade. It compares the required version and the locally version which is currently running. If they match, it skips the next step and goes to the configuration file. If they don't match, it does code upgrade or downgrade with the reboot. Then the device comes back up, and then there's the configuration file stage. It takes the file. If it is a configuration file, there are basically two options. If it is a configuration file, it just attempts to commit it. If the commit is successful, process is complete. If commit is not successful, it tries to fetch the configuration file again and repeat. Also, you have an option to feed a script to a device to run. This script will be covered in the next slide with the option, but yeah, so you have this option. If the script is not run for any reason, there is a problem with the script, it will try to fetch script again and try to run it again in a loop. Oh, and yeah, now it's time to talk about Phone Home ZTP. So the Phone Home ZTP is supported on certain hardware, certain software version, and it relies on the Mist AI cloud as a leverage. So in this case, what device does, it gets DHCP address assigned, right? So it has external reachability. It tries to reach the Mist AI cloud redirector using TCP 443. If it is not able to reach it, the process restarts and ZTP just starts from over. If it is able to reach the cloud, the cloud will provision certain configuration, including the authentication required to communicate to the cloud, to the device. Commit happens on the device, and then device opens outbound SSH connection via TCP 2200 back to the Mist cloud. And then as soon as this communication is up, and this is the main channel how it communicates to the cloud, final configuration template is pushed, and then the Phone Home ZTP is successful. Another name for Phone Home ZTP is Phone Home Client, or PHC. Let's compare ZTP versus Phone Home ZTP. Phone Home ZTP just requires basic DHCP configuration, like IP address, subnet mask, DNS, and default gateway. The regular ZTP requires advanced DHCP configuration with several parameters to make sure that ZTP is working properly. File repository, local file repository is necessary for ZTP. Theoretically, it can be local or remote, it doesn't matter, but we need it. For regular ZTP, you don't need internet access, just local access. For Phone Home ZTP, you must have internet access. Configuration application. ZTP can do basic or full. The difference is the basic is shared parameters, just some not device-specific parameters, while full has everything, shared and device-specific. Phone Home ZTP can do automatically basic configuration, not device-specific. You still can do it, but it requires a few clicks in the interface or utilizing Mist AI API. Automatic code upgrade downgrade, ZTP can do it. Phone Home ZTP can do it, but it will require, again, either manual clicks, a few buttons, or API of Mist AI. I would say that ZTP is the best use case for campus DC networks or service providers networks as well, where you have a large scope of devices, you have well-templatized environments, you use multiple devices of the same kind. And then Phone Home ZTP is great for branch retail, where you have a lot of small branch offices, where it is sometimes hard to keep additional server for a repository for DHCP. And even if you try to centralize it, the traffic will go over insecure media like internet, and this can be a security concern. While Phone Home ZTP talking to Mist is completely encrypted in transit. So this is why this is a better suitable option. Also, Phone Home ZTP has an associated license and subscription cost because it is using Mist Cloud Wired Assurance feature. Encrypted control channel, again, I mentioned that. And finally, also, while it has subscription cost, Mist AI provides you a lot of benefits like troubleshooting, using AI, remote access from the cloud to the CLI, a lot of great options which are very useful. But yeah, this is in terms of ZTP. Let's talk about next the hardware support. This is as of today, as of end of 2024. You will see the platforms which support ZTP on the left and platforms which support Phone Home ZTP on the right. So Phone Home ZTP is supported by a set of EX switches, NFX, QFX, and SRX, and also SSR. They communicate to Mist Cloud. ZTP has more platforms which support it, including PTX, MX, ACX. This is just hardware, so you can see some devices which you may be interested in. If you'd like to learn more about the software version, you go to Feature Explorer down below. This is where I found this information. As soon as you go to Feature Explorer, you click Explore by feature, and then you search by feature name. Feature name you see in the top. So this is how Juniper calls these features internally. Or you can just search ZTP or any other feature, right? And there you will see your platform and the code you need. So let's go back. ZTP phone home client is outside the scope of this video. We'll focus on the ZTP. So let's look at the options required for ZTP, DHCP options. On the left side is Junos. On the right side, Junos EVO, next-gen operating system, running on certain devices, multi-device models. Let's talk about left side first. You see option 150, which is the standard DHCP option called TFTP server address. And you need to provide IP address, IPv4 address of file repository. FQDN is not supported here. Then option 43, vendor-specific information. So here inside, you encode, using different codes, a bunch of information. Code 0 is image file name, so you provide a path on repo server to your image file. Config file, the next code 1 config file name, you provide the path to your configuration file. Code 2, this is image file type, it's called symbolic link. Basically, this thing is technically optional, but if you omit it, if you don't provide this code, it will treat the information in code 0 and code 1 as a file name. It's okay if all your files are just stored in the root of your server. However, if you use the folder structures, like in my case, I use configs folder and images folder. You may use like Juniper, other vendor, it's some kind of structure, hierarchy. In this case, you need the Juniper to treat that text string as a symbolic link to make sure that it understands that it is not the file name, but the full path. In this case, you need to provide code 2 with the symbolic keyboard inside. You will see further in the examples how it looks like. Code 3, transfer mode. Transfer mode can be either FTP, HTTP, HTTPS, or TFTP. Then code 4, it's called alternative image file name. It's actually exactly the same as code 0. The difference is that some DHCP servers may not support code 0. And in my example, a few years back, I was testing, and the Kea DHCP did not support code 0 back then. And I needed to use code 4 instead. Today, based on my current testing, code 0 is supported for option 43 in Kea, so that's why it's better to use code 0 and just omit code 4. If you use code 0 and code 4 at the same time, code 0 takes precedence. Code 5, HTTP port. So this is HTTP or HTTPS port, which you can, again, provide a custom port to the device, which it should use to download. Okay, so now let's look on the right side, EVO. The good thing is that it's almost identical. You see a difference in the code names, but it's not a big deal. Under the hood, it's all the same. The main difference is you can notice there is no code 5. You have another way how you provide the custom port to the device, and you do it in the bottom. There is example when you provide the image file name, file path, and image in the configuration file path. You just add colon and the port number to the end of both strings. There are no other differences. Later in 18.2 R1, there are 2 more codes were added. Code 7, which is FTP timeout, type string, optional. You can add the timeout in seconds. Code 8, proxy information. So it is a string, also optional. And you can just provide the IP address, colon, port of the HTTP or HTTPS proxy server. Let's look at the configuration file. So configuration file which you need to provide to the device, it must be in the Juniper hierarchical format, which is in the example. Don't use display set. You should use this format. And as I mentioned before, you can use script instead of the file. How device will understand that this is a script is just by looking at the first line special characters. It will be just a hash sign and then exclamation mark, and then the path to interpreter. It can be a shell script, Slack script, Python script. The couple important notes. For the Python script, Juniper, for security reasons, Juniper limits unsigned Python scripts to only Junos OS with enhanced automation images or Junos OS EVO. And another note is in starting release 21.1 R1, ZTP Python scripts must be Python 3. Python 2 is no longer supported. Let's talk about popular ZTP approaches. I can divide them into basic and full approach. The difference is that in basic approach on the left side, ZTP will upgrade the image of your device, and then ZTP will apply basic configuration file. So you can notice that in repository there is just one file. called SW. And this basic configuration file will hold shared configuration part like radius, local accounts, protectory, syslog, SNMP, etc. But then you will need one extra step, either manually or using automation, to finally customize all devices by adding the unique configuration part to them, like IP addresses, dynamic routing, hostname. In the full approach on the right side, after OS is upgraded by ZTP, the full configuration is applied to the boxes. In this case, you can see there are 3 different switches and there are 3 different configuration files in the repository. So each device will get its own instructions to get its own configuration file, and you don't need any more steps here manual. So this is true zero touch. Let's compare them further. So we have first thumbs up going to the basic because it is a low maintenance scenario. You don't need to hold each configuration file and keep it updated because you just have a standard configuration file or portion. The right side needs to keep updating all those switch configuration files. Next thumbs up goes to basic as well. It's just from the DHCP configuration, it is a simpler way because it just requires one kind of reservation. While on the right side, you will need to custom reservations for different switches because you need to provide different set of options. The third one, thumbs up, goes to full because this is true zero touch. You don't need additional steps. Next one goes to basic, and because it is great solution for the large scale deployments when you have hundreds of typical devices. And it's just hard to maintain hundreds of configuration files. Still possible if you use some kind of automation, but yeah, so this is one of the options to consider. Next thumbs up goes to full, and it is excellent choice when you have a mixed model, use case, vendor scenario. In this case, it is much easier to have unique configuration files and make your life easier. And finally, they are both great, or we can say that thumbs up goes only to the full, because in case of RMA, the full is better because it will hold the current up-to-date configuration file. And even if device goes immediately down and you cannot fetch the configuration from it anymore, you can have still an option to download the version of the code from the configuration from the repository. And the RMA replacement will be a breeze. Next, DHCP logic. Let's look here. So we have a repository holding multiple images, configuration files. We have DHCP server running. We have firewall to reach outside. We have an out-of-band management network, and then we have 4 devices connected down below. So let's say each of these devices needs ZTP. But what we see 3 Juniper devices of different product lines. We have non-Juniper device here. And now the problem is how DHCP server will distinguish between them. How will it understand that it needs to send one image to EX4400 and completely different image to PTX, right? Because they can't run the same image. Okay, so the first option is MAC address. MAC address is globally unique. Each device can have a unique MAC address. We can use the first half of the MAC address and use wildcard to determine a vendor. However, it may be not enough because, as we saw, we can have 3 Juniper devices and they are not the same. Also, imagine that you need to deploy a new EX4400 and you have it in the box. And you look and you take a picture, or a technician takes a picture and sends you the sticker on the box. And you look at the bottom and you see MAC address empty, right? So you don't see MAC address on the side of the box. However, you see a model and you see a serial number on the box. So it basically gives us the idea that MAC address is not the best choice, not the worst, but not the best. And next we are looking at this 4400 24 NP. So how it works under the hood in the ZTP scenario. It has out-of-band management interface on the right side in the back. It's called, the interface is VME, and it runs family INET, INET6 DHCP, and it has MAC address B. While the rest of the interfaces, they are running in the layer 2 Ethernet switching mode, and then members of VLAN default, and then there is IRB0 on top with INET and INET6 DHCP. And it is different layer 3 interface, it has different MAC address. So it basically means that the technician can plug the cable in the back or in the front, and you will see a different MAC address. So you cannot rely on MAC address, or you need to provide additional instructions for that. A couple more examples. SRX 320 runs ZTP only on two interfaces, on port 0 and port 7. It doesn't run it on other interfaces. It, however, runs DHCP on them in the server mode. But again, this is unique for SRX scenario because SRX is ready to go and work out of the box. These two interfaces, they're configured with family INET, and they run DHCP. Because there's two separate logical interfaces, they have different MAC addresses. And example for EVO, PTX 10001 36MR runs ZTP on the out-of-band management interface, as well as all inboard interfaces one by one, treating them as a separate family INET 6 interface with a unique MAC address each. Again, the whole idea here and conclusion that you need to verify documentation for your specific hardware to make sure that you understand what interfaces run ZTP on. And probably you can find even further information there as well with the recommendations, platform specific. But there is a solution. It's called VCI, Vendor Class Identifier. It is option 60 of DHCP. And another option which may be useful is option 12 called hostname. And these are DHCP options which are sent by the client toward DHCP server. So, and we can see that option 60 contains 3 different parameters divided with a hyphen. It has Juniper, and then the model name, EX4424MP, and then serial number. And option 12 hostname has just serial number in it. So this works as an introductory node to a DHCP server. Hey, this is who I am. So next one is, let's look at the box and the label, which we've just seen. And here now you can see that, okay, we see a perfectly matching model and the serial number here, right? So, okay, now we can attach our box to our output from the DHCP logic. And this is sample PCAP from the same device. And we can see that this is a discover message moving out, and we see option 12 and option 60. So this is what is going out to the DHCP server. Okay, and then there is another example, SRX 320 discover message for 23.4R2S2. Again, you will need to double check either documentation or to do a test to make sure that what your device is sending. Because in this case, you can see option 12 is not being sent. Option 60 is being sent just as Juniper SRX 320. It does not add a serial number in the end. So this is again platform and code specific information. I would expect these to change to that same logic as EX does it in the future. So just follow up with the code change. Meanwhile, what we can do, we can rely on the model plus MAC address probably, but it will require some additional steps to know that MAC address by running the device probably and checking. Next, there are again a couple examples from virtual products. VMX on the left side, vJunos switch on the right side. And you can see they do send option 12 and option 60, again following that example. The difference is the delimiter, and this is quite important. VMX in this case uses colon as a delimiter, while virtual vJunos switch uses hyphen. So I would say colon is the best possible option because colon is not used in serial numbers or models, while hyphen can be used in the model. So it will be important when we look at the configuration, and I'll explain it in detail. How will we choose DHCP server? There are two most popular options in the market being used. Both are open source, both are distributed by ISC. The ISC DHCP on the right side, it is end of life in 2022. So this doesn't get any more updates, but it is still being used on some customers. And there is a Kea option, which is currently supported DHCP solution, and both support IPv4 and IPv6, by the way. The advantages of Kea over ISC, first of all, high availability, more features, IPv6 support. Well, both support IPv6, but Kea supports more options, and also ongoing support. And then next, flexible configuration. So you can configure your server remotely using API. You can push the configuration and apply it without restarting the server, and etc. And also multi-threaded performance. So it's better performance on the multi-thread, multi-core hardware. And another, I would say, is the template format, because Kea now uses JSON format. Okay, next step is we'll look through the configuration. First, we'll start ISC DHCP for Junos devices. On the left side, it's basic approach. On the right side, full approach. We'll start on the left side, top to bottom. The brown text is a custom variables definition. So this is where we define our variables with codes and options. Next, black text is a default configuration portion. I just haven't changed it. It was present in the configuration file. Then green text is IPv4 pool configuration. So we have our subnet, we have range, we have default gateway and DNS servers. Theoretically, you could put other options right here under the subnets, but it would send them to everybody, which we don't want to. So how we can bypass it? In this case, we can use next portion, which is purple, is called client classification. So now we can classify clients based on certain information client is sending to us. And then I create the class, I give it a name, and then I use match. If this match will be true, all the options down below are being sent to the client. If it is false, not. In this case, I'm doing substring option vendor class identifier 014. So what it means? It means that basically take a portion of a string starting with the character 0 and next 14 characters and match them to Juniper-EX4400. So if it is Juniper EX4400, regardless of the serial number, we are providing this information to it. And you can see we provide image and we provide base configuration file, like shared configuration file portion. Also, we provide symlink, as I mentioned, because we see a path is basically in hierarchical structure. It's not a complete file name. And then we have transfer mode, etc. The difference between basic and full is in the match string and the config file name. In the full, we send a specific configuration file just for that device. And we do match if string option vendor class identifier 2015. So we start from character 20, next 12 characters, and this should be a serial number in that string. You can see a string here above in the green oval. Yep, and another thing is if you have 3 switches, on the left side you just need one class. If you have 3 switches on the right side, you will need to create 3 classes for each switch, providing each different configuration here. Otherwise, they will be the same. Next example for EVO, Junos EVO ISC. Basically, it's almost identical. The difference only is in the thing that we don't use code 5 anymore. We don't define it here, and we don't make a string in the class for the option. And also we provide the port, if you need to provide a custom port, in the end of the config and image names. Same idea on the right side. Next is Kea DHCP configuration file. It's longer, it's JSON based, which is great. And we'll start from the top left. The blue text shows what interface the server is running on. Black portion is default configuration portion. I haven't changed it. The brown portion is the definition of the variables. Same idea, logically, just a different structure. So here we define all our variables, its types and names. Next, client classes. This is similar to class feature in ISC. So we basically create a class, name, give it a name, and then we do test instead of match. Test will do split option 60-4. What is it? So it basically takes option 60 and split it with a delimiter of hyphen. In this case, in our case, we'll have 4 different portions: Juniper, EX4400, 24MP, and serial number. So I'm looking at the number 4, and this is serial number. So this is a difference enhancement over ISC. In this case, you don't care how many characters are in the serial numbers, which is great. If it would be with MX, where the colon is, it would be even better, because it will be colon and then 3, because it will always be 3. In this case, depending on the model, it can be 3 or 4, because hyphen is not a unique character. And then option data, you must set this vendor encapsulated option string, otherwise option 43 completely will not be sent. So this is basically where that it indicates that it needs to send it. Everything is being encoded inside with different codes, and then it goes as a massive string out. And other information encoded as well. Next, green text is the configuration of the subnet. So same idea, we set subnet, we set range, default gateway, DNS, nothing special. Basically every client which will connect gets this data. but they will get this data from the class only if test string is true. And the last portion is the default configuration. I haven't changed it. Let's look at the comparison between basic and full approach. Again, same idea. On the left side, we just matched that it starts with Junos EX4400 and provide base config. On the right side, we verify serial number using split -4, and then we provide the unique custom configuration file. For EVO, same idea, again, no code 5, and port is set in the end of the line. Again, in this case, you can omit it. I just put it as an example. If you use a non-standard port, right, like 8080, for example. What if you don't need ZTP process? What if you would like to cancel it? You would like to manually configure your device. When device boots out of the box, you will see these messages popping up in the CLI. And you will also, and this is indication that ZTP is running, they will be going and going. If you would like to stop, there is a message on CLI, apply delete chases auto image upgrade and commit. So you go to configuration mode, you do set your root password because it will be required for the first commit, and then you delete chassis auto image upgrade, and then you commit, and then ZTP is over. Let's look at some output for the successful ZTP attempts. This example from QFX 10272Q. So first of all, we'll see what interfaces the ZTP is running on. Next, we'll see, okay, that some options are being received by the DHCP server, from the DHCP server, and then we'll see message all options set. So it means device is satisfied and is ready to go to the next step. And it starts ZTP and shows us the summary of all the information that we'll be using. Then it starts fetching config file downloaded. Then it is fetching image downloaded. Then it starts the installation process. Then it basically mentions that the reboot will be done. And then it is going down. And then finally device comes back, you log in, and it requires password because now the custom configuration file is configured. And finally, you are inside the box. Success. Next example is for EVO, for PTX 10136MR. The output is a little different because it's different operating system, but the general idea under the hood is the same. It also runs ZTP and also shows you the message that if you would like to abort, remove just that configuration portion. And then it receives options from the DHCP server. So we have IP, subnet, default gateway, and our parameters. Also pay attention to the end of the string. This is how we provide custom port 8080 here and there down below. So next it starts working, it downloads the image, which is .iso. And then it downloaded image. And then you can also notice alternative image, because as I mentioned, this was tested back then, a year ago or so. Next, we are downloading configuration file downloaded. And then we are running code upgrade. And then upgrade succeeded rebooting, it restarts the system. And then upgraded software and rebooted, so done. And then loading new configuration loaded. ZTP finished successfully. For the ZTP on EVO, you have a useful command show system ZTP. You can see state succeeded, and then you can see all the details of the ZTP. It is very helpful if you are troubleshooting or collecting the output for your maintenance window as a report. For the IPv6, if you would like to go this way, you also need to double check Feature Explorer first. And find the features of ZTP features related to IPv6 and search for your model and search for your code version. This is always step one, because not all devices who support ZTP support or not the same code version support IPv6 ZTP. IPv6 ZTP has the similar structure to the options. However, the number of the options is different. So instead of option 150, IPv6 is using option 59, and it requires IPv6 address, like in the example. However, it does not support FQDN as well. Option 17 instead of option 43 for vendor-specific information. Inside, it's basically identical. However, I don't recommend to use code 5, and I would recommend to use like EVO example, when you don't use code 5 and you just add a port, as you can see in the top. after the IP address. So in this case, it's just easier and unified. Otherwise, the rest is identical. Another thing which I would recommend here is keep in mind that if you have multiple interfaces running DHCP v4 during ZTP, which obtain DHCP address, they will be tried in sequence. They will try first, not successful, they will go to the next, and so on. If you have DHCP v4 and DHCP v6 addresses at the same time, it will try v4 first and then v6. And also, again, in my opinion, I don't see much advantage of IPv6, IPv4 versus IPv6. So in this case, if you would like to go further and beyond, and you would like to try something new, I would recommend you to probably go and glance into the future and look for this option. So this is a feature called Secure ZTP or SZTP. It is currently supported on 6 different models with the latest hardware: MX240, MX304, 480, 960, and 2 PTXs, 10004 and 10016. This is RFC 8572 based SZTP, and it enables mutual authentication between something called bootstrap server and the network device before provisioning. So let's first of all cover what is the limitation of the regular ZTP. In the regular ZTP, as I mentioned, repository is authentication-less. So it means it does not require authenticating for someone who is connecting to get image or the configuration file. You can restrict, let's say, your FTP server to work only in download mode, right? It will not allow anybody to upload, but still it means that anybody on your network who have access to that repository, they can download all your configuration files, which is not that secure, right? Still, you can do some measures, isolating out-of-band management network, etc. But still, this is still possible because it's clear text stuff. Another thing that it is theoretically vulnerable to hijacking. A bad actor can set up rogue DHCP server and provide rogue DHCP options and rogue configuration file to the device in case of ZTP, and then hijack the device, right? So clear text, yeah, limitations. In this case, this basically solves the problem. You create something called bootstrap server. It is not a cloud, it is your local server, but you need to interact with Juniper to set it up. You can read further in the documentation because it will require vendor certificate. And then the device itself, each device, current modern device coming out has a TPM 2.0 module on board, which hold a cryptographic device identity. And then when device starts initiating the secure ZTP, it still interacts with the local DHCP server, which shows, it basically points it to that remote bootstrap server using a special option, new stuff. And then your device connects to that server via the encrypted channel, and they are able to mutually authenticate each other. So device will not trust anybody except trusted bootstrap server. And bootstrap server will only trust to a certain device which has this TPM module on board. Yeah, so this basically solves all the security concerns of the ZTP. If this is something you are interested in, and if these devices are of your interest, yep, see further documentation for details. And why I would consider going this route instead of IPv6 is just after reading the note below. The note below calls the current ZTP, which I was talking about, a legacy ZTP. And it basically shows that hardware which supports SZTP will no longer support legacy ZTP. It means there will be, sometime in the future, there will be a hard transition from regular ZTP to secure ZTP. So that's why if you would like to go anywhere farther than regular IPv4 ZTP, probably go to secure ZTP if the platform supports it, obviously. So now it's time for lab demo. So I'm going to show you, this is my lab demo setup. I have a subnet. I have a EX4400 running 23.4R2S2 down below. It's in amnesiac state, a factory default. It is connected to out-of-band management interface, to my out-of-band management switch. And this switch currently shuts this interface down. So switch booted, it's ready, but the interface is shut down. I have repository server on it I have two images, S2 and S3. I will be providing S3 to the switch as instructions, so it will be upgrading to S3, as well as it will be downloading this code configuration file from the repository and applying it during ZTP. So let's go and proceed to the demo. Currently I'm connected via the console to the test device, and I'm going to log in using root. It doesn't ask for the password because the device is in the amnesiac mode. Usually it's not required. It's just an option for us to see the messages as they are going, as the device going through ZTP. So currently, as I mentioned, the uplink is shut down. So what I'm going to do, I'm going to enable uplink, and we'll see what's going on the device. Here, meanwhile, we can see that state reset. So it basically means that everything starts from scratch. We see unbound interfaces. So these are interfaces ZTP is running on, but there is no address there yet. And the bound list is empty. One down below it's empty. So no interfaces have IP address. And after that, it tries phone home ZTP, which later fails because there is no internet access yet, or a network access. Okay, now we see that we are getting some options here, right? So these are the options coming from the DHCP server. And now we can see one interface is in bound state. We see a summary of the information we got for the ZTP, and ZTP proceeds. It starts fetching config file downloaded, and then it is downloading. Currently it is downloading the image, which is S3. Currently the device is running S2. It's using HTTP. You're downloading from this repo IP using the management interface. So it's again a great detail if you are troubleshooting and if you need to double check how your setup is working or why something is not working. So it will show you all the messages right here. Yeah, it will take a moment. And yes, it's fetched, so the image is downloaded. Next step is to go through the upgrade. So it reminds us that system will reboot automatically upon installation. And currently it's being upgraded. So next, if you would have the same code version already installed, it would just tell you right here that skipping this step because the code is already running, and then it will go to the config portion. In our case, it needs to perform installation, so it will do installation and reboot, and then it will push the configuration file. Okay, so the device is back. So let's log in. Sometimes it happens, you can see we logged in and it didn't require us the password. So what it means the device stays in the default configuration state. So we just need to exit and just give it a few more moments until it will complete the configuration step. So usually after the boot, I would wait for a minute or two if you're doing testing. Just don't log in immediately. It needs to process some ZTP logic internally. So this is a great example. Yep, let's try again. Yep, you can see it asks for the password. So it basically it takes about 1 to 1.5 minutes to finalize the configuration. And then I'm doing show configuration, and you will see this is my test configuration from my server. Just root authentication services, SSH, and VME interface. So that's it. And let's do show version. And you will see that the current version is S3. So it concludes our lab demo. Now you have all the details you need to start and use ZTP in your network. Leave a comment if you have a question, subscribe, and see you in the next video.